Hello friends and welcome to this video. In this video we are going to analyze the beam problem using ANSYS 2020 R1 Mechanical APDL. Myself NV Patil, Assistant Professor in Mechanical Engineering Department, and I am going to show you how to solve the cantilever beam which is loaded by point load at one end and also having the UDL. So let's see the problem statement. So this is the cantilever beam which is loaded by the point load of 5 kN at the free end and also having the UDL 4 kN per meter. The length of the beam is having total 5 meter span. The cross section of beam is a rectangular cross section having dimensions 0.1 meter by 0.06 meter and the value of E is 200 GPa. So as this ANSYS Mechanical APDL is the unitless software, so we need to define all the data in the same form of unit. So we are going to define the forces in kilonewton and length in meter. So we need to convert this E value as a 200 GPa into kilonewton per meter square. So you know that the conversion is 200 into 10 raised to 6. And these values we are going to define in the ANSYS. So let's see how the problem can be solved using the ANSYS APDL. So for this purpose we need to open the ANSYS software. So for this click on the start icon and type APDL. So you can see here it will be appear as a mechanical APDL product launcher. Click on this icon and the ANSYS window will be get open within few minutes. Now you will get this window on your screen. You can able to set the working directory by clicking on this browse icon. You can also able to give the job name. So I am here giving the job name as a beam because we are going to solve the beam problem. Now leave this window and click on this run icon so that the ANSYS will be get started. Now you will be get this ANSYS window on your screen. So there are main three steps: pre-processing, processing and post-processing. So let's start with the first step. First we need to click on this preferences, structural, OK. The next step is to click on preprocessor, element type, add. Again click on add, and for the beam problem we have to define the element as a beam. So there are different elements are available in this window. So we need to click on this beam and it is a 2-noded 188 element. So click on OK. The element will be appear here. The element name is beam 188. Now close this window. Now next we need to define the material properties. So click on material models, then structural, linear, elastic and isotropic. So this is our assumption that the material is in isotropic in nature. We need to define here the value of E, and as this is again a unitless software, so we have to define all the values in the proper format. So we are going to define here the forces in kilonewton and the length in meter. So the E value 200 GPa is converted into a kilonewton per meter square. So the value is 200 into 10 to power 6. So we are going to define as a 200 E6. Poisson's ratio is 0.3. Now click on OK and then close this window. The next step we need to define the section for the beam. So click on section, beam and common section. Now here the different sections are available like rectangular section, taper section, circular, hollow, C section, I section, L section and so on. As per the problem statement, you need to select the proper section and then define its dimension. If you select the I section, then accordingly you need to define the dimensions. In our case, we are having the rectangular cross section, so we need to define the B value and H value. So B value is 0.1 meter and H value is a 0.06 meter. Now click on OK. Then next step, we need to create the modeling. So in modeling we have to click on this create icon and define the key points. So as you can see in the problems, here we can able to define the 3 key points. So this is the first key point, this will be a second key point and this will be a third key point. So the first key point we are going to define at the origin, second key point at 3 meter length from the origin, and the third key point is at 5 meter from the origin. So in this sequence we are defining the key point in ANSYS. So click on key points, then in active CS define here the key point number as a 1. Here this value you need to define as a x coordinate, y coordinate and z coordinate. So here we are only defining the x coordinate values. So if you not define any value, by default it will take as a 0. So first node will be appear at origin, so directly click on apply. The second node is at 3 meter from the origin, so click on again apply. And the last node, that is the third node, is at 5 meter from the origin. So this is the last node, so directly click on OK. So you can observe here these 3 nodes are defined. Sorry, 3 key points are defined. The first key point is at origin, second key point and third key point. Now we need to join these 3 key points by using the lines. So click on lines, again line and straight line. Now pick this key point number 1 to 2 and again 2 to 3. So it will be get joined with the straight line. Click on OK. Minimize this modeling icon. Now we need to apply the meshing. That is, we need to discretize the given element. So click on meshing, click on mesh tool, click on line set, select this first line as second line, click on OK. You will be get this new window. Here you can able to define the edge length or the division. Now I am going to define the division as a 30. So each line will be get divided into a 30 number of parts. So you can use any number of divisions. So it will be depending upon the accuracy criteria and time required for the solution. Now click on OK. Again we need to click on this meshing tool icon. So it is disappear. So to appear it again you need to click on this trace hidden icon. Now click on this mesh icon again. Select these 2 lines. Click on OK. Again click on trace hidden icon and close this mesh tool window by clicking on this close icon. In this way the meshing will be get applied. And now we need to check that proper meshing is applied or not. So click on this plot and multiplot. You can observe it is defined, element are defined, lines are defined, key points are defined and nodes are defined. Means the meshing is properly get applied. If you not seen any one of these, then your meshing is not correct. So you need to reapply these steps. Due to this discretization and meshing, these elements line is get divided into a number of elements as well as number of nodes. And to check the number of nodes, you can click on this plot control numbering. Here the different options are available. If you click on the key point numbers on, you can able to see the key point numbers. If you click on the line numbers, you can able to see the line numbers. Same fashion node numbers. So if I click on this on and click OK, so the node numbers you can able to see. If you zoom this beam elements, it gives the node number as first number, then second number at the end point, and again starting from 3, 4, 5, 6 up to a 31 number, because we are dividing it into a 30 parts. Again the 32 number will be applied at the end of the second line. So you can observe here the 32 number is again going to apply at the end, and again it will be starting from 33, 34 up to a 61, because we are dividing it into a 30 parts. So total will be get as a 61 nodes. Now again I am going to opt this numberings. So clicking on numbering, opt the node number and making the key point numbers on. So it will only show us a key point numbers, that is 1, 2 and 3, because we are going to apply the loads and boundary condition at these respective key point numbers. So we can click on this fit view, so it will appear on your screen properly. Now we need to apply the boundary condition. So minimize this meshing, then click on this loads, click on the define load, apply, structural, displacement and on key points. So first key point is fixed, so we have to select the first key point, click OK, and all degrees of freedom must be log. If you not giving any value, it will be taken as a 0. So you click on OK. So you can observe this first key point will be get fixed, and at key point number 3 the point load is applied. So we need to again minimize this displacement, click on force movement, Again on key point, select the key point number 3, click on OK. The force is in y direction, so we need to select the Fy, and the value is 5 kilonewton, and it is in downward direction, so that's why we have to select -5. Click on OK. So this force will be get applied, and at this portion there will be a uniformly distributed load. So as you can see in the problem statement, the point load value is 5 and UDL value is a 4. So these values again we are going to define. We already defined the point load. Now here we need to define the uniformly distributed load. So to define UDL, we need to click on this pressure icon, select on beams, select the box window, and select using the box icon up to this key point number 2. So it will, all the elements will be get selected. Now click on OK. New window will be appear. The load key we have to type as a 2 because the load is acted in a y direction and the value is 4. So type as a 4. At node J, no need to type any value because it is a uniformly distributed load. If it is a varying load, then at both node you can able to apply the different values. For the UDL, only need to enter the single value. Now click on OK. So the UDL will be get applied. So all the boundary conditions and all the load data are defined. Now we need to solve this problem. So to solve this problem, again minimizing this load data and click on the solutions, solve and current ls. Click on OK. You will be get this solution is done message will be appear on your screen. It means all the data you have defined is a proper and you will be get the result. If you not getting this message and if error message will be appear, then you need to again define your steps in a proper way again. So now close this window, again close this icon. To see the results, go for the general post processor. Now here we can able to see the different types of results. Also we can able to plot our result. So our first aim is to find the deformation. So to see the deformation, click on this list results icon, click on nodal solution, click on degree of freedom, and the deformation occur in y direction. So click on y component and OK. Click on OK icon. So you will be get this deformation at the different nodes. At node number 1 the value is 0. At node number 2 the value is -0.13. So minus sign indicates the deformation in downward direction. So at each node you will be get the deformations, and the total nodes are 61. So every node you will be get the deformation and its values, and the maximum deformation will be occur at node number 32. That is at the last node, that is at free end, and its value is -0.2849. The value is in meter because we are giving all the values in meter. Now close this window. If you want to see the reaction, you can click on this reaction solution icon, select this. Reaction will be occur in y direction, so select this Fy, click on OK. You can see the reaction will be appear at node number 1, which having value 17 and kilonewton because we are applying the load in kilonewton. And if you see the result figure, you can get the same value. So this is the result diagram where we can get the reaction at first node, that is 17 kilonewton. We are also getting the bending moment at point A, that is 43 kilonewton per meter. We can get analytically the shear force diagram, bending moment diagram. In bending moment the value is 43 and shear force the maximum value is 17 and minimum value is a 5. Using ANSYS we can also able to plot this shear force diagram as well as the bending moment diagram. So let's see how to plot these diagrams. Here the reaction will get the same value as a 17. Now close this window. To plot the shear force diagram and bending moment diagram, we need to define the element table. So minimize this, click on this element table data, click on define table, click add. Now go for the last one by sequence number and define the value SMIC and 3. Click on apply. Now we will get this warning. Suppose if you get such types of warning, then you need to write one command in the command prompt. So for this purpose, first we need to close this warning message. Click on the resident icon and close this element table data also. So click on cancel, click on close, and in this command prompt we need to type one command as a set comma last. Hit the enter key and again follow the same steps. So click on again element table, define table, add, go for the last one by sequence number, click on 3, apply. So here it will be get applied. Now again click by sequence number 6, apply, again by sequence number 16, apply, again by sequence number 19. Now this is the last one, so click on OK. So this 4 element table data we have defined. Why this 4 data we need? If you click on this help icon and search for the element table data for the beam 188, then you can get the answer. So I have already opened this help menu, so I am going to show you. So this is the output data for beam 188 element. Here you can observe this mz, that is a moment about z, can be defined by using number 3 and 16. So we require a combination of 3 and 16 to get the bending moment diagram and the shear force in direction y. So we require the number 6 and 19. So we require a combination of 6 and 19 to get the shear force diagram. And the items are SMIC. So that's why it is defined in the ANSYS as a 3, 6, 16 and 19. So that's why these 4 numbers are defined here, and we need to use the proper combination to get the shear force diagram and bending moment diagram. Now close this window. To see the shear force diagram and bending moment diagram, click on this plot results, click on contour plot, click on line element result. Now here you need to select the proper combination. So 3 and 16 will give you the bending moment diagram. So click on OK. So you can observe here this bending moment diagram. The nature only is in opposite direction. You will be get the value as a minus 42.16 and here value as a minimum value as a 0.16. By analytical calculation, we get the bending moment as a 43 and 0. So it is again closer to the actual values. This ANSYS is again a numerical method. So we get the approximate results and not a accurate results. So you can observe this result diagram. You can see here this bending moment value is 43 and at this location is a 0. And for shear force 17 and 5. So same values we also get by using the ANSYS, very close to the actual results. So these are the same values which is very closer to the actual result. Now to see the shear force diagram, again click on line element results and we need to use the combination of 6 and 19. Now click on OK. You will get this shear force diagram. The nature only is in opposite. We get the value as a minus 16.8 and in analytical we get the value as a 17. So this value is again closer to the our result and the minimum value as a 5. Now if you want to capture this image, click on plot control, click on the capture image. So you can able to capture the given image. Also you will be able to save this image at the different location by clicking on this save as icon. Now close this window. In same fashion also we can able to plot the different results also. Now suppose we have to plot the deformation, then you can click on this nodal solution, degree of freedom and deformation in y component. Okay. So you can see here the beam will be get deformed and its value at this point shown by the color code. So blue color it will be shown by as minus 0.2849 and this minus sign is due to the downward deformation and at this value the value is 0. So this is the color graph which will be shown and these values according to the color codes. Node number 1 is fixed, so there is no deformation. If you want to see the actual beam, then you can able to see by clicking on this plot control, style, then size and shape. Then click this on, that is a display of element, click on OK. So you can able to see the actual beam element if you click on this isometric view. So as our beam is having the rectangular cross section, so you can able to see this actual beam also. You can also able to animate the deformation of beam using the animation. Again for this, click on this plot control, click on animate, click on deform shape, and then click on OK. So you can observe here the beam will be get deformed due to the application of the load, and by changing its speed you can observe the animations also. So in this way we can able to get the different types of the results like deformation, reaction, and also able to plot the different results like shear force diagram, bending moment diagram, deformation results. So I hope you have enjoyed this video, and now you will be able to solve any type of beam problem using ANSYS mechanical APDL. To stop this animation, click on this stop and click on this close icon. Thank you for watching.